class, how are you? Welcome back. Today I'll go with physics session, that is the very good chapter of your 9th class, that is force and laws of motion. This chapter is quite easy, only the conceptual is there. Concepts has to be very clear. Now, as the name of the chapter is force and laws of motion. Yes, 9th class, force already you have done in your 8th section, and even in 6th, 7th also you must have studied about force. It is the push or pull of an object. Yes, but yes student, now this is the 9th section. You need not to go with this line. It is not the push or pull of an object. No, this is not correct. Now then what actually the force is? What actually the force is? Force, now come. Force, it is an influence on any object. Influence means we are affecting that object. Clear? It is an influence on an object which tends to, what happens when we are applying force on any object, that tries to or tends to set an stationary object, that is rest, into motion, or if any object is moving, sets into rest position. Okay, so it is an influence. Whenever we are applying force, it is an impact on that object of that particular force which we are acting. Yes, we are applying. It is an impact. Means what happens? What is that impact which is there on the object? Either from rest position to motion, or if it is in the state of motion, it comes to its rest. This is the first condition. Second, it may change the shape, size, yes, and direction. It may change the, suppose if I am applying force towards that direction, particular direction, it will start moving, the object will start moving towards that direction. Maybe east, west, north, south, or any of the direction I am talking about, it can change the direction. It can change the shape. It can change the size. Suppose if you take a balloon and you press it, what happens? What happens? It will, yes, the size will decrease, or what happens? Shape will change. Yes, so direction may change, size, shape, any XYZ is what, when we are applying any force, these are the impacts which applies on an object. That object will show these impacts. Object will show. That is, then finally, what is the term force? Force is, yes, it is an influence which tends to set, yes, which tends to set a stationary object or the rest object into motion, or if any object is in the state of motion, it will, yes, set it into rest position. Clear? Motion, suppose if any object is moving, I applied force, the object stops. If any object is in the state of rest, if I apply any force, it will start moving. Yes, and size, shape, direction, any XYZ that can change. Yes, so these are also called the effects of force. The question may come, what is force, or what are the effects of force? Clear? Now the next topic is, when I have started force, then see, now it is not the push or pull. Clear student? Now, what are the types of forces? Already we have studied in 8th section, that is contact force and non-contact force. Contact, when the object is in contact with each other, they are touching each other and the force is being applied there. Clear? For example, muscular force. If I am applying any object, I have to touch that with my body or the muscular force, and what happens? The body will move or comes back. That is, contact, the two bodies has to be in contact with each other. Clear? Another example is frictional force. What is frictional force? When your object is moving, when any object is moving, it is the opposite force that is, yes, opposing that force which is allowing it to move. So, frictional force, then what? Muscular force. These are all examples of contact force. Now, what is non-contact force, student? Non-contact force, that means the body is not in contact, but the force is applied. For example, if I am talking about electrostatic force. What is electrostatic? That is electrical force which is positive and negative. They are not contacting with each other, but they are showing the effect. And electrical, yes, electrical energy starts. So force is there without contacting the body. Another example, students, magnetic force. If I bring any magnet near some iron object, it will attract. That means without touching, the nails or the iron object will attract towards the magnet and stick to it. This is non-contact. Clear? And besides, 9th class NCERT, in your book, there is balanced and unbalanced force, which is again very, very important. Now, what is balanced force? If I'm talking about this object. Now, this is the object. Two boys are applying force on that object. Suppose if I am F1 and you are F2. One of the boy, if he is F2, he is applying exactly same to that of my force. If I am applying 5 Newton force and yes, from your side that boy is also applying the 5 Newton force, then what happens? Both the forces are equal but opposite. I am standing this side of an object and that boy is standing another side, opposite side. And when both are applying same force, equal and opposite, that means yes, balanced force will apply. The body will not show any change. It will not move. So what is balanced force? When F1 is exactly equal to F2 but opposite in direction. So this is known as force, that is balanced force. That is F1 is equal to minus F2. And what is the resultant force? What is the meaning of resultant force? That is the net force applied on an object. Net force, total force, what is the total force applied on an object is known as resultant force. 1 mark question. What is resultant force? It is the net force applied on any object. So here net force from that side and this side. So F1, if I am F1 and one of you comes and he is F2. What happens, student? I am applying the force of 5 Newton on that object or the box there, and he is also applying the same force, that is of 5 Newton. But what is the difference? He is standing that side and yes, opposite direction. Right? I am this side, he is that side. So force is opposite. Force is opposite direction. But though it is equal, then it will not show any change. Object will remain as it is in that position. And the total force, that is F1 plus F2, is equal to 0. Yes? So, yes student, what is balanced force? In which the total force is 0 and it is always equal and opposite and body will not show any change. Now the next is, what is then unbalanced force? Unbalanced, as it's same, unbalanced means it is not balanced. Clear? Suppose if the object is there, I am applying 5 Newton, okay? But that side, that boy is applying 3 Newton. Yes, whose force is lesser? F2. Then when I am applying force, my force is larger and I am applying, the box will shift towards that side. That is towards F2. So, because my force is greater, so F1 is greater than F2. Clear? Maybe that side he has got 7 Newton, I have got 2 Newton. What will happen then? F2 is greater and F1 is lesser. So, maybe F1 is greater than F2 or F2 is greater than F1. Or F1 and F2 is never equal. Never equal, though opposite, but it will never equal to each other. So, that time we will call it as unbalanced force. And in balanced force, the body will not show any change. It will remain in that position. Here, the body will show movement. Yes, student. So, body will show movement. And here, the total net force is non-zero. It will not zero. Non-zero, the value will come. The value will come. Resultant force is non-zero. This type of force is known as unbalanced force. See, it's such interesting. Nothing is there, only conceptual. Once you have come to know, easily you can handle with all those questions. Yes. Now, next is, what is, another term is there. What is, one thing more, force is a vector quantity. What is vector quantity? It shows direction and magnitude. We can measure force In my second law, I'll explain you how we can measure. Magnitude is there and it has particular direction. So force you are applying and must be the body will move. It must be some direction is there. So force is vector quantity. Clear? Next, before I start with laws of motion, the term what is an inertia? What is inertia, student? It is an ability of an object. Suppose I am standing and teaching. It's my tendency of my body to be in this position. If I want to sit, I will sit. That is, every object has an ability to be in that particular state, maybe rest or in the state of motion. Yes, student, that is tendency, it is the ability, we can do it. Or the object has an ability to be in that particular state. Maybe it is in the state of rest or maybe it is in the state of motion. So, what is inertia? It is an ability or tendency of an object to be in the state of rest or of motion. Clear? Now let's start with laws of motion. Newton was a scientist, Isaac Newton. He also discovered gravitation and here Newton discovered different laws of motion and these laws will help in our physics. When we are studying about laws, that means in daily life we are using this. The applications are there by using these laws that I will discuss all the examples which we can see. Yes, student. Now, what first law says? What is first law? Listen very carefully. According to Newton's first law, when an object is in the state of rest, it will remain in the state of rest. Suppose body, if it is in rest position. Sun is in rest position, correct? It will remain in the state of rest. Remain. If the body is in the state of motion, it will remain in the state of motion like planets. Until or unless an unbalanced, external unbalanced force applied on it. Very, very important. Body remain in the, suppose if I am keeping one body somewhere here. Until or unless if I applied any external unbalanced, why I am talking about unbalanced? Because I have to move that object. It is in the state of rest. So I have to apply unbalanced then only it will move now. Balanced, the body will not move. So any external unbalanced force is applied, then only the object will move. If the force is not applied, year after year that object will remain in that particular state. See Newton where he checked this. Like sun, million and trillion of years, sun is in state of rest position. Until unless when it will change its position if any external force acts on it. No external force is acting on it. So sun is still in the state of, inertia of rest. Inertia, ability of a sun, ability of an object to be in that particular state. Another example, if the planets are continuously revolving around the sun, that means planets are revolving from million and trillion of years. It will keep on revolving until or unless some external unbalanced force acts on it. If some unbalanced force acts, then the planet will stop. Planets will stop moving. Clear? So, finally, what is Newton's first law? According to Newton's first law, when the object is in the state of rest, it will remain in the state of rest. If the object is in the state of motion, it will remain in the state of motion until unless some external unbalanced force acts on it. Yes, student? Clear? Now, let's go with examples, then only it will be clear to your mind. First example, why the leaf detaches when we are shaking the branch? Why the leaf detaches? See. Listen carefully. Here we are talking about inertia only because detaches. It has an ability to detach. But when? It will detach. Correct? Yes. So first law is also known as Galileo Law of Inertia. Galileo was a scientist who, with Newton also discovered this law. Clear? So law of inertia or Galileo's law of inertia. Now why the leaf detaches when the branches are shaken? Initially, both branch and leaves are in the state of rest. No external forces there, it will remain in the state of rest. What happens? A man came and he shaked the branch. Branch comes in the state of inertia of motion. But, yes student, continue. Branch comes in the state of motion, inertia of state of motion, because the man is shaking the branch. But leaves are still in the state of inertia of rest. They don't want to move because they are not moving, only the branch is moving. So when the branch is moving, leaves tend to be in the state of inertia of rest and it detaches. Very easy. One is in rest, another is in motion. Another example, when we flick a card, suppose you take one beaker, on that you keep one card and one 5 rupee coin on that card. What happens if I flick a card? Card will move and the coin will drop into that tumbler. Why? Because we are flicking a card, not the coin. Coin is still in the state of inertia. You have to mention inertia of rest. Coin is still in the inertia of rest. Initially, both are in the state of inertia of rest. That is coin and card. But when we are flicking a card, the card is in the state of inertia of motion, but coin is still in the state of inertia of rest. So, it drops down into the tumbler. Clear? When the carpet is beaten, the dust particle comes out. Why? The carpet is beaten, the carpet starts moving due to the inertia. Clear? And dust particles are still in the state of inertia of rest and it falls down. Clear? Another example, why the passenger falls forward and when the bus stops suddenly. Why the passenger? Now, this is the passenger and bus. Clear? Both are in the state of inertia of motion. But what happens when the bus stops suddenly? The passenger falls forward. Why? Very important question. 2 marks question comes. See, initially both are in the state of inertia of motion. When the bus stops, the lower part of the body is in contact with the bus. When the bus stops, the lower body comes in the state of inertia of rest, but upper part is still in the inertia of motion, takes time to come to the rest. So, what happens? Lower part is with the bus, so it stops, and upper part is still in the state of inertia of motion and he falls, yes, he falls forward. Then what he will do? He has to, yes, hold something so that he will not fall. Clear? And same, why the passenger falls backward when the bus starts suddenly. Initially, both passenger and bus are in the state of inertia of rest. Bus starts suddenly, the lower part of the body of the passenger is in contact with the bus. So, lower part along with the bus moves ahead and upper part tends to remain in the state of inertia of rest. Wants to be in the state of rest because lower part goes ahead with the bus. So, he falls backward. Very easy. Only logics are there. Once you come to know about all these explanations, you can easily handle with all these questions. Another example is why it is dangerous to jump out of the running bus. Bus is in the state of inertia of motion. Passenger was also in the state of inertia of motion. But when he is jumping down, the road is in the state of inertia of rest. When he is jumping, then what happens? His lower part is touching with the, yes student, ground, and upper part is still, what happens? It's still in the state of inertia of motion because he was in the bus. When he jumps, what happens? He may fall forward. So to avoid this, the passenger or the person has to run along with the bus for some time so that he will not fall. So, it is dangerous to jump out of the running bus. Why the luggages are tied on a roof of the bus with a rope? Because bus may stop or may start and luggage may fall forward or backward. Yes, so that is why it has to be tied with a rope so that it will not come in the state of inertia of motion or in the state of rest. Clear, student? This is the first law. Very easy. Force, first law is over. In my next video, I'll go with second law and the derivation, how the force can be measured. This law defines the force. One mark question. Name the law which defines the force. That is first law of motion. Name the force which measures the force. That is second law of motion. So there are three laws. In my next video, I'll continue with second law of motion, third law of motion, and conservation of momentum. With that, along with this topic, I'll continue with the numericals also. Yes, 9th class? Clear? Okay then. Thank you so much for watching, and please like, share and subscribe. Thanks for your love. Thank you so much, 9th class.